In this video, we'll be talking about the fact that the properties of addition do not translate to subtraction. This can be a big source of error for students because the tricks that they learn to make addition easier, they try to use on subtraction, but they're not valid. Let's go ahead and look at some examples. So there's no commutative property of subtraction. In addition, we can say a plus b is the same as b plus a. In subtraction, that's not true. So let's look at an example where we can see this. In this addition problem, I could choose to add 1 plus 4 or 4 plus 1. It doesn't matter. I get the same value. If I wanted to start with my larger 10, my 6, and add 2, that would be fine. I get the right answer right here. It doesn't matter how I add my numbers in each column, what order I add them in, because we have the commutative property of addition. Subtraction, however, that's not the case. A really common error with students is rather than using the subtraction algorithm, they just say, oh my gosh, I'd rather subtract 4 minus 1 as opposed to 1 minus 4. So 4 minus 1 is 3, 6 minus 2 is 4, and my answer is 143. Well, clearly that's not correct because we started with 121 and then we took away and ended up with a bigger number. That doesn't make any sense. We should have ended up with a number that was less than 121. So order matters in subtraction, and this is a common mistake where students will decide that they can subtract in any order, but that's not true. We also have no associative property of subtraction. Let's remind ourselves what this is for addition. With addition, if we're adding three numbers together, we're not going to change the order for this property. We're going to change the grouping. So I could group the A and the B, or I could group the B and the C, and I'll still get the same answer. This is not true for subtraction. If I have A minus B minus C, and I decide to group the A and the B, versus grouping the B and the C, I'll get different answers. Let's see how this plays out. So here, if I want to look at 7 plus 3 plus 2, I could first add the 7 and the 3, group those together, and get 10 plus 2. Or I could decide that I want to group the 3 and the 2 together, where then I'd have 7 plus 5. This ends up with 12, regardless how I did my grouping. So this is a good process. Either one I can do. With subtraction, if I group the 7 and the 3 versus the 3 and the 2, I'll get 4 minus 2, which is 2, or 7 minus 1, which is 6. So I can't solve this problem by saying, well, let me first take 3 minus 2 and then subtract that from 7. There's no identity property of subtraction. With addition, I can add 0 in any position to A, and I always end up with A. With subtraction, well, if I subtract 0, then I still have B, but if I flip this around and take 0 minus B, then I'm not going to get B as my answer. The last one we want to talk about is the fact that the whole numbers are 0, 1, 2, 3, are not closed under subtraction. Whole numbers are closed under addition, which means if you take any two whole numbers and add them up, you'll get a whole number as the answer. And so you can have some fun games, that use this fact. If you wanted to have a die, either a 6-sided one or they have fancy ones with lots of different sides, and you roll the first number and you write it down, it's 1. You roll the second number, you write it down, it's a 5. You know that when you add those two together, you're going to get a whole number. It's going to be 6. So that could be a fun way to practice addition, having some kind of random number generator there. But if you turned right around when you were studying subtraction and said, well, let's roll the die and let's use that to come up with numbers to subtract, if we were to take roll 1 first and then roll a 5, well, 1 minus 5, we're going to end up with negative 4. Obviously, that's not an appropriate example for, say, first grade because we haven't learned about negative numbers. We don't get a whole number as an answer. whole numbers are not closed under subtraction because if I take any two whole numbers, I don't necessarily get a whole number answer. Here I got an integer. So that would be an appropriate problem to do in middle school. It's not that we can't solve this. Of course we can solve this, but this is a middle school level problem where we're dealing with integers, not an elementary problem where we're first learning subtraction. So we just have to be a little careful in how we set up our subtraction. The takeaway is just because it works with addition, don't assume that it works with subtraction. So let's look at a great example here of when a mental math strategy for addition fails us in subtraction. So if I wanted to add 47 and 28, I could subtract 2 from the 47 to give me 45, and then turn right around and add 2 to the 28 to give me 30, and get the answer of 75. And then I could check this with my standard addition algorithm and see that I got the right answer. That's a great strategy. If I try that same strategy for subtraction, I could subtract 2 from 47 and get 45, add 2 to 28 and get 30, and then I would think that my answer was 15, but when I go to check this, I can see that the answer is actually 19. And so this was not a good strategy. So just because it works for addition, we can't assume that it works for subtraction, and our students will often make this mistake.